Okay, volumes of evolution. Now these questions tend to be in context, so you're going to need to read what they're talking about. So they give you a diagram, lots of words about the curve and what's happening, and some information. They start out with they want to know the maximum depth of the bird bath. So they mean by that the maximum depth of the bath bit, how much water we can get in. Use that bit. So then you have a look through all the information. Here we've got the curve there that this is going to be modelled by, and so you can see from this curve that when x equals 0, y equals 1, which means that point there is going to be 1, and then if you look at this diagram we've got the maximum height, which means the bird bath should be 0.16 metres deep. Then they want us to find k, so there must be some information in here that we can use. Well, let's have a look. So when x is 0.2, this height here must be 1.16, because that's what it said over here. So 1.16 is 1 plus k times 0.2 squared. If you then rearrange that, we should get k equals 4. So now we know our model. Right. Now, we need that in order to find the volume of concrete that's required to make the bird bath according to this model. So, it's going to be completely solid of concrete here. So that's what I mean when saying the volume of concrete here. And you've got to now imagine in 3D what's going to happen. So to get a 3D model, we need to rotate this curve about the y-axis. Okay. So we need a rotation about the y-axis, and you're going to have to think about what happens. So we've got our curve here. Okay. So it's this line here, which is the curve. Now if I rotate the curve only starts here at y is 1, and I'm going to get the area between the curve and the y-axis, and it's going to be rotated round to give us this bowl shape. So that's 1.16 and that's 1. And then you need to remember your volumes of revolution formula. So we're going about the y-axis, so that's going to be pi integral, it's going to be dy. The d bit at the end, if you want to try and remember it, tells us which axis we're going around. So it's going to be x squared dy. Those two things are always different. Now, if we integrate the curve, as we said, starts at 1 and goes up to 1.16. So that's going to be our limits. We then need to find x squared. So I'm going to take our equation and rearrange that. So we're going to get y minus 1 equals 4x squared. So x squared is a quarter y minus 1. So we're going to integrate this. Oops. You can leave the quarter inside the bracket, or if you remember that constants, as long as everything that you're integrating is multiplied by the constant, can go outside the bracket, we could write that as a quarter of pi at the front. And then I'm only integrating y minus 1. Volumes of revolution, you must show your integration. So and then we're going to show substituting in our limits. Okay, and then we can work all that out, and you should get that as your answer. You must show some working, don't just put this in your calculator. Okay, then we need to put this in context. So what's this found? Well, this found this blue bit, which is the bowl. Okay, obviously that bit's not actually going to be filled with concrete. What we want is this bit here. In order to get that bit there, what can we do? Well, we can look at a big block, okay, which if you imagine rotated round will be a cylinder, and then we could take off the bit we're going to hollow out. So we now need to think about the volume of the cylinder. Okay, so that's going to be circular at the bottom, which is pi r squared, the area of a circle, and then it's going to be multiplied by the height. So that's pi. Let's have a look at our cylinder. So our radius is going to be 0.2 and our height is going to be 1.16, the total height. Okay. And then we could work that out as well. Okay, so then we're going to get the volume of the bird bath. So that's going to be the volume of the cylinder. And we're going to take off the volume of the actual bath bit that would be filled with water. What does it want us to do? It wants to give us an answer in meters cubed, 3 significant figures. I have to admit I did forget to check that all our units were in meters, so do check that in case they give you any measurements in centimeters. Okay, and so I can put that to 3 significant figures with my calculator. Right, so limitations and models. Now you just want to think of something most sensible here. So what did they allow here? Well, it could be that the measurements of the bath aren't accurate. Okay. So imagine when you measure something, it's quite hard to be really accurate with this bath. You could have perhaps, so this is a very smooth bowl, but the bowl might not be smooth. Whether that's through decoration or just wear and tear or just isn't poured in smooth, it could be anything. If you're making it from the concrete, you could waste concrete when you're making it. So you'd have to be very accurate to use the exact amount of concrete if you were pouring this into this mould. Right, so you probably want to get this fairly, you need to kind of get the answer accurate to be able to answer E accurately. So it's later discovered the volume using concrete used to bath was this, 0.127. Use this information and your answer to evaluate your model. So you can see you've got higher than that. So there's different things we could do here. I will just copy those in from the mark scheme, save me some writing. Right, so you can see here that it's a comment consistent with your values. So they did allow a follow through for some probably more sensible answers. But you do have to have a reason. Okay, so you can't just say over or underestimate. So for example, you could find a percentage error and say it's not very good because it's 7% out. Or this was quite a good practical reason here. So particularly if you put that you thought there might be wastage of concrete. So you could say that you'd expect the model to overestimate, but actually it's underestimated. So it's the important thing here is that you must have a reason in context.